Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence. Today's episode is titled Vision Beyond Sight. In this presentation, we'll delve into groundbreaking research published on December 7, 2025, featuring 164 papers that push the boundaries of computer vision. Discover how machines are learning to see and understand the world, transforming industries like healthcare and agriculture through innovation. This journey through computer vision will cover several key areas. First, we'll dive into the dominant themes shaping the field, such as environmental monitoring and robust machine learning. Next, we'll highlight key findings from recent studies, including advancements in deforestation detection and media manipulation. We'll also spotlight seminal papers driving innovation and discuss future directions for research, providing a comprehensive overview of this dynamic field. What exactly is computer vision? It refers to the ability of machines to interpret visual data much like humans do. This technology spans applications in healthcare, agriculture, and entertainment, enabling computers to recognize objects, track movements, and even reconstruct scenes in three-dimensional space. By combining mathematics, neuroscience, and engineering, computer vision allows systems to not only see, but also comprehend complex visual scenes, making it one of the most impactful areas of artificial intelligence today. A dominant theme in recent research is environmental monitoring, particularly in tracking changes for a better world. For instance, Christian Masao Konishi and his team have developed a method to detect deforestation in the Amazon rainforest with an impressive F1-SCORE of 80.41%. Their approach combines different models and processing techniques effectively, demonstrating that standardized methods can improve both transparency and computational efficiency. This work provides practical tools for environmental agencies while setting new standards for methodology in the field. Another significant theme is robust machine learning under challenging conditions. Chandler Tim C. Deloriel and his colleagues introduced the mask-to-adapt method, which achieves an error rate as low as 8.3% on corrupted image datasets. Remarkably, their use of simple random masking outperforms more complex uncertainty-based methods. This technique proves particularly practical for real-world dynamic environments, paving the way for more efficient deployment of computer vision systems in unpredictable scenarios. Media manipulation represents yet another exciting area of advancement. Zekai Luo and his team have enabled high-fidelity face swapping, pushing the boundaries of creativity and realism in cinematic quality. Similarly, Yichuan Huang's research focuses on generating voxel art from 3D meshes, further expanding the possibilities for creative expression. These innovations highlight the growing capabilities of computer vision in media generation and manipulation, offering new tools for artists and creators alike. Across these studies, several key findings stand out. Konishi et al. Have set new standards for deforestation detection, achieving remarkable accuracy through strategic model combinations. Deloriel et al. Demonstrated that simplicity can sometimes outperform complexity, as seen in their mask-to-adapt approach. Meanwhile, Jiun Pio and colleagues highlighted significant gaps in spatial reasoning, with current models achieving only 38% accuracy compared to human-level performance at 84.87%. These results collectively underscore the progress and challenges in addressing real-world applications. Shared methodologies across these studies reveal common techniques shaping the field. Attention mechanisms and transformer architectures excel at capturing long-range dependencies and complex relationships in visual data, though they often demand substantial computational resources. Masking strategies, whether applied in spatial or frequency domains, enhance robustness under corruption, but may struggle with fine-grained details. Hierarchical approaches preserve structural consistency during segmentation tasks, but can increase false positive rates. These shared methodologies reflect both the strengths and limitations of current approaches, offering insights into the evolving toolkit of computer vision researchers. Let's examine a seminal paper by Christian Masao Konishi and his team on detecting deforestation areas in the Amazon rainforest. Their primary objective was to improve existing methods for deforestation detection, which often lack effectiveness or standardization. They evaluated various change detection models, including traditional fully convolutional networks and newer architectures, incorporating self-attention mechanisms based on transformers. By systematically investigating pre- and post-processing techniques, they achieved an F1-SCORE of 80.41%, marking a substantial improvement over previous approaches. This research provides a standardized methodology for comparing different approaches and offers practical solutions for environmental monitoring agencies, balancing accuracy with computational efficiency. Another groundbreaking contribution comes from Chandler Tim C. Deloriel and his colleagues, who challenged conventional wisdom about the complexity required for effective test-time adaptation in image classification under distribution shifts. Their proposed solution, called Mask-to-Adapt M2A, generates short sequences of masked views, either in spatial or frequency domains, and adapts models using two objectives: a mask consistency loss that aligns predictions across different views, and an entropy minimization loss that encourages confident outputs. Through systematic experimentation, they demonstrated that M2A spatial achieved mean errors of just 8.3% on CIFAR10C, 19.8% on CIFAR100C, and 39.2% on ImageNet-C, all at severity level 5, outperforming or matching more complex baselines. This work paves the way for more efficient and practical deployment of computer vision systems in dynamic environments. Finally, let's explore Xiong Piao and colleagues' development of FRIDA, a benchmark for multi-step cartographic reasoning in vision language models. This work addresses a fundamental gap in our understanding of how well current models can reason about geographic information. Unlike previous benchmarks that treated maps as specialized charts, FRIDA specifically targets the unique challenges of map interpretation, including layered symbology, orientation-dependent relationships, and cross-map reasoning. The researchers evaluated 11 state-of-the-art vision language models under two settings: direct, where relevant maps were provided, and contextual, where models had to identify appropriate maps before reasoning. The results revealed a startling gap between current model capabilities, around 38% accuracy, and human-level performance, 84.87%. This research establishes a clear benchmark for progress in spatial intelligence and highlights specific areas where current models fall short. Looking ahead, several directions seem particularly promising for computer vision research. There's a growing need for more standardized evaluation protocols across different application areas, similar to what FRIDA provides for cartographic reasoning. The success of relatively simple techniques like random masking suggests that sometimes less complex approaches might be more effective than anticipated, encouraging researchers to revisit fundamental assumptions about model design. Finally, the increasing focus on multimodal approaches and hierarchical representations points toward more integrated ways of processing visual information that better reflect human cognitive processes. Balancing technical sophistication with practical applicability will remain a central challenge, while the pursuit of more explainable and efficient models will drive innovation across various application domains. This presentation was synthesized using advanced AI tools including GPT, QuenMax, DeepGram TTS, and Grok image generation. While these technologies streamline content creation, the deck has been reviewed by human experts to ensure accuracy. Potential oversights are acknowledged, and references to original sources are provided for further exploration. This synthesis process exemplifies the collaborative potential of AI and human expertise in creating informative and engaging content. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.